data set. My data originally had 130 values, and now in my sample it has 30. In my summary sheet, I chose the body temperature data, and right next to it in column B is the standardized data. This represents how far these values are away from the mean in terms of standard deviations. And next we have the frequency distribution, and this just includes the minimum, maximum, number of classes, class width, lower class limit, upper class limit, and the frequency. And if we scroll down, we'll see the mean, mode, mid-range, range, variance, and standard deviation. And directly next to it in the blue, we have the 5-number summary. The 5-number summary just gives us a general picture of what the data will look like. And if we scroll up, we can look at my histogram. Um, this histogram is skewed to the right. The most relevant measure of center for this data is the median, because the median is more resistant to outliers compared to other measures of center. And the closest measure of center for this particular data would have to be the mean, because if we look in our data at 97.5, it is the closest to 0 in the standardized data. And if we look at the mean right here, it is 97.49. And in this data, there is a few two standardized deviations from the mean, and those are the ones up here. We have 96.3, which is a negative 2.781 standardized deviations up below the mean, and then the 96.7, which is very close to standard deviations. These are just outliers, and I think this rule just proves that. Moving on to the confidence interval, the question I am answering is, using your sample, test the claim that the mean heart rate for this population exceeds 70 beats per minute using a 90% confidence interval. Our point estimate is 7187, the standard deviation is 5.11, and the confidence level is 90. The sample size, or N, is 30, and the lower is 70.28, and the upper is 73.45. So, in conclusion, I am 90% confident that the mean heart rate for this population exceeds 70 beats per minute on my list between 70.28 and 73.45 per one person. Moving on to the hypothesis sheet. So we have the question that I'm answering, which is, using your sample, test the claim that a majority, 50% or above, of the body temperatures for this population is below 98.6. If we scroll down, I scroll back to my data in column A, and we look in column B, which is my counter, which is basically like a counter argument. All of this is below 98.6, so there is absolutely no way for me to have any counters. My N, or my sample size, is 30. My P is 0, because 0 divided by 30 is just nothing. And then my claim P as a decimal is 0.5. My significance level is 0.05, and it does mention lower. My null hypothesis is P equals 0.5, H0 equals P equals 0.5, and then my alternate hypothesis is H1, P is greater than 0.5. The test statistic is negative 5.477. Critical values is negative 1.644. My p-value, again, is 0. So my conclusion is that at the 0.05 level of significance, I would say that a majority of greater than 50% of body temperatures for this population is below 98.6. The sample does have a significant evidence to say that the majority of the body temperature is below 98.6.